Decimal, binary, hexadecimal, and conversions. Decimal is base 10, binary is base 2, and hexadecimal is base 16. What the base number represents is how many characters is being used in the numbering system. So base 10 means that there are 10 characters being used in the numbering system. As we can see here, 0 to 9 actually represents the base 10 system. Okay. Base 2, since it's based on two numbers that can represent, an infinite amount of numbers, only uses ones and zeros. Base 16, or hexadecimal, has 16 characters being used in its numbering system. 0 to 9, just like decimal, and then A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. Base 16. Now, what I have here is the values, which is 8 values or 8 bits, which represents 1 byte, that we're going to be converting a decimal number, into binary, and then from binary, we're going to convert that number into hexadecimal. Now, these numbers, 1, 2, 4, 8, 16, 32, 64, 128, is how you are counting the values in a base 2 binary system. 1 represents 2 to the 0, 2 represents 2 to the 1, 4 equals 2 to the 2, 8 is 2 to the 3, 2 to the 4 is 16, 2 to the 5 is 32, 2 to 6 is 64, and 2 to 7 is 128. Now, let's go right in. Let's grab a couple numbers. Let's say like 70. Let's say like 224. And let's get a low number like 12, right? So the first thing when you want to do when you're converting a decimal number into a binary number is you have to match these values to equal the decimal number. So starting from left to right, you basically are going to look for the values that are lower than the decimal number, and you're going to subtract this value from the decimal number, right? So let's first start off 70, right? So 128, we can't use this value because it's already greater than 70. So we're going to give that a 0. 64 is actually smaller than 70, so we can use this value. So we're going to give it a 1. And over here, we're going to do 70 minus 64 equals 6, right? So this 6 basically means that we only need 6 values left in bits to equal this decimal number of 70. So 0, 0, 0, right? 4 and 2 and 0. It's so simple. 70 in decimal is 0, 1, 0, 0, 0, 1, 1, 0. Let's go to the next one. 224, okay, which is larger than 128. So we can subtract 128 from 224. So we'll give this value a 1. 224 minus 128 equals 96, right? So from here, 96, this 64 can fit into 96. So we're going to take this value too and do another subtraction. 96 minus 64 equals 32, right? 32 is the next value. 224 in binary is 1110 0000. So simple. And let's do the last decimal number, 12. 128 is too large, 64 is too large, 32 is too large, 16 is too large, 8, right? So we do 12 minus 8 equals 4. 4 is the next value. We give that a 1, we're done. 12 in decimal equals 0.00001100 in decimal form. Now let's go into hexadecimal form. The easiest way to convert a decimal number into hexadecimal is to convert it into binary first. And when we convert it into binary, these values here slightly change, right? So what happens is where you see 16, 32, 64, and 128, it actually becomes 1, 2, 4, 8 all over again. So what we do is we can draw a line, right, separating these two values, okay? So this is going to be 1, 2, 4, 8, 1, 2, 4, 8, okay? Let me see if I can write over this. Let's see, we do a large 1, 2, 4, 8. It looks sloppy, but we're going to have to work with it. So if we want to convert this decimal number into hexadecimal, all we have to do is deal with each side separately. Now, I explained before that 8 bits equals a byte, you know, and when you have 4 bits is actually called a nibble, Nibble. So you take one side at a time, okay? So let's start here. 1, 2, 4, 8. We're going to add these values on this left side, right? So the only value that we need to add is the value that we have, which is a 1 in the 1, 2, 4 space. So this would be a 4. Let's put a 4 right here, right, on this side. And we're going to add these two values. 2 and 4 is 6. Let's put a 6 on this side. So basically, 70 in binary is 0, 1, 0, 0, 0, 1, 1, 0, and 70 in hexadecimal is 46. That's why I said it's simple to convert the decimal form into binary, and then you chop the binary in half to convert it into hexadecimal. Let's do the same thing for the next one. All you do is just add the values of ones on each side, and you use that value and find that value in the hexadecimal form. It will not be over 15, okay? So whatever value is added is going to equal something over here. Again, 1, 2, 4, 8, and then we're going to do 1, 2, 4, 8, because we're doing hexadecimal, okay? So if we add 2 plus 4 plus 8, we get 14. So over here we can put 14 in hexadecimal, I'm sorry, is E. So we're going to put hex here, E. And on this side, we don't have any values. So the value for 0 in hex is 0. 224 in hexadecimal is E0. So simple. And let's do the last one, 12, right? Cut it in half. 1, 2, 4, 8. Okay. It's a 0 on this side. So we know that the first part of hex, let's write it over here, is a 0. And then over here, we're doing 4 plus 8, which is 12. And 12 in hexadecimal is what? C. So 12 in hexadecimal is 0C. And there you go. Binary, decimal, and hexadecimal conversions. Peace.